Another most commonly used fertilizer is urea ammonium nitrate. It's a liquid. Maybe you know that, maybe you don't. Either way, it doesn't matter. It's a liquid. How do we make this? This is, I'm driving home the point here that practically every single nitrogen fertilizer on the market is generated from its starting point, its parent, which is anhydrous ammonia. And that is the case for urea ammonium nitrate. So urea ammonium nitrate is created by reacting anhydrous ammonia with nitric acid to form ammonium nitrate. Now, this used to be a common fertilizer in the US years ago until the Oklahoma City bombing. And purchasing this, you could still purchase this product. It's a great product because it has both ammonium and nitrate, and it overcomes an electrochemical imbalance because of the use of nitrate within cells, right? Remember, nitrate is taken up preferentially to offset electrochemical imbalances due to the uptake of cations. And it's also used to overcome the energy balance within plants. If plants take up ammonium, they don't have to expend as much energy to convert ammonium to amino acids and proteins. It's a great fertilizer. However, because of the Oklahoma City bombing, we now use other types of fertilizers like urea ammonium nitrate. And when we take ammonium nitrate, after this step, we react it with urea to create urea ammonium nitrate. So where did we find, or where did we get, or where did we create urea? We created urea from anhydrous ammonia, reacting it with CO2 under temperature and pressure. So when you're in the fertilizer industry, you're typically not making one type of fertilizer. You're probably making multiple forms of various fertilizers, and I hope that's evident here. The other thing that is not evident, but I'll tell you, is that typically there's another factory or process nearby that's creating either a product or a byproduct of nitric acid. And so typically industries are married to one another. For example, the oil and gas industry is typically married to the fertilizer industry. And so if you find one, you typically find the other in a location, FYI. So this is a liquid, right? It's a liquid fertilizer. The analysis of the liquid varies depending on temperature, and that's called salting out. And it's sort of shown here, all right? So here's temperatures. It's called the salt out temperature, and I'll explain this hopefully halfway decent in this description. When the temperature is very low, materials tend to precipitate out of the solution, and thus the overall percentage of total nitrogen decreases in the liquid phase. As the temperature increases, some of those precipitates redissolve into the liquid phase and increase the amount of total nitrogen in the liquid phase. And that's what you see here. And there's a bunch of numbers on this table that are important. In fact, the most important number I think on this table for this class is likely the density of that liquid. And oftentimes this density value will be given to you, and you need to know what the density is in order to calculate an application rate of urea ammonium nitrate. And we are going to do that in this unit. That's just a prelude. So when I think about the loss pathways, it has urea in it, and it has ammonium in it. And so when you think urea and you understand the chemical reactions that urea undergoes to eventually become ammonium, one of the end products is ammonia gas, right? So you should first think of volatilization. This product is susceptible to volatilization losses, not as great as urea. And we shared that with you in the previous video on urea fertilizers. So some applications or application considerations and some soil reactions that we'll discuss. The advantages of this product is that it's liquid, right? And so because it's liquid, it's more accurate and uniform in terms of its application. You're not just broadcasting prills or putting prills in a band underneath the soil. You're actually injecting the liquid, actually probably dribbling the liquid across the soil surface. It's easy to band or subsurface band. You can band it in a liquid, applying the liquid slightly above the soil surface, or you can inject it down into the soil surface as you drive your implement. It's very safe to handle. It's not going to blow up on you. You can easily combine other liquid fertilizers or pesticides with this liquid. And if you're using fertigation, for example, in a greenhouse or maybe a field study or in field conditions where you're growing high cash crops, it can be used in fertigation. There are some disadvantages. It can cause leaf burn. And so if you're applying this product on a leaf surface, you want to, as soon as you can, water to wash this product off the leaves. Typically, we recommend no more than about 10 pounds of urea ammonium nitrate per acre with the seed. That's another disadvantage. Greater than that, you can burn the seed as well. But it's a wonderful fertilizer. You can actually use this very, very easily under no-till conditions. And I work with a producer that actually does this year after year after year.